Hello students, today we are going to discuss the data warehouse schemas. The schemas are the basic syntax or structure in which we stores the data, and in data warehouse the schemas are quite different from the normal DWMS schemas, which are normally generally tables. So here, instead of using the simple table, we use some other kind of schemas like star schema, snowflake schema, and the fact cancellation. The cancellation. And what are these? Now I'm going to explain you about all these. The schema is the logical description of the entire database. It includes the name and the description of the records of all the record time, including all associated data items and aggregates. So, date. So it means that in data warehouse, first of all, we are going to discuss the star schema. The star schema is just like star. There is a central schema in which all the attributes are expanded and represented in a single dimension with the help of a key. And all these keys can be further extended. In this way, all the dimension in the star schema are represented with only one dimensional table. Like in this diagram, here we can see that there is a sales fact table which is lies at the center, and it has the six attributes: time key, item key, branch key, location key, dollar sold, unit sold. Here the item key, that is a code, can, item key that is a code is x, and this dimension is represented in a simple code, and this is expanded represented with help of one dimensional table, item dimension table, that contains item key, item name, brand type, and supplier types. Similarly, the time key, that's also key, is represented with the one dimensional table that contains day, day of the week, month, quarter, and year. Similarly, the branch key is expanded as the branch key, branch name, and branch type. And the location key with the help of street, key, province of state, and country attributes. So in the center table, sales effect table, these values are stored in a coded format, and these code restores this information related with these attributes. So like we go to the mall, and there we visit that everything there we visit, and we find out that everything has a certain barcode. With the help of that barcode, we can find out what is the actual product, what is the name of that product, what is the brand of that product, its type, its suppliers, the day of manufacturing, and the location where it has been produced, and the particular store which is selling it. So all these information are stored in the simple barcodes, and as it is very concise format, we have actually coded all these information. In this way, we can see that in the star schema, the center table stores just the key values, and these key values can be replaced by the one dimensional table, which uh, elaborate the particularly one dimensions information. So this is the simple kind we can, by using one dimensional table, basically there are two advantages. First, the complexity is removed, uh, and the second is resolved, and the second one is that it is kind of normalization. Here the many data items, for example, I am talking about a dimension table. Many some particular brand may produce a lot of items. So instead of repeating, there there could be number of items. Suppose a company Van Heusen is producing a selling a number of producing manufacturing a lot of type of t-shirts, and every shirts will have a barcode, and the same information, the particular brand, time, and supplier will be printed with every item. Instead of writing all these again and again, we can just simply replace with the barcode. So this remove the redundancy and reduces the size of the database. So it's a kind of normalization. So we can say that the we do not need to repeat the information that can be reduced. And instead of write, just we shall write at last that the code related with this stores these value, and for the rest of the item of the same information would be marked by the similar kind of code. Next come the snowflake schema. The snowflake schema is the uh, enhancement of the star schema. The same table that we have used in the star schema can be one second. The same table is used here, and here we can see that the sales table. One second, please. The same table is here, but there is a difference that here the item dimension table, where has four attribute: item name, brand, type, and supplier key. Here we find out that the supplier key is also in coded format, and it has been further elaborated with the help of supplier dimension table, which stores two values: supplier key and supplier types. And in similar way, in location dimension table, the city key is a code, and it has been elaborated with the three dimensions: the city, province of a state, and country. Here one dimension is the difference is that some dimension in the snowflake schema are normalized further, or we may say that in this normalization we split up the data into some additional tables depending upon the attributes. And if there are attributes which are more complex, or which need much elaboration about the property attributes they involve, then we need to perform the snowflake schema, in which one dimension is split into some other dimension table. In this way, it is the expanded form of the normalization in comparison to the star schema. This is called the snowflake schema. Here in star schema, there was a restriction that each key should be expanded represented with the help of only one dimensional table. But here, uh, dimension table can be splitted into more than one levels. So depending on the attributes, so it is normalization to another level. So due to normalization in a snowflake schema, the redundancy is reduced, and therefore it becomes easy to maintain and save the storage. There are some attributes which have which they have many complex attributes or multi-value attributes. Then these can be defined in a better way with help of the snowflake schema. Then at last comes the fact cancellation schema. This is called also the galaxy schema. If two schemas which are related to each other share some common dimensions, then they can you they can share some common dimension table in between them. The diagram shows here that the sales table is the same that we have used earlier, but the shipping fact table is related. The sale and shipping are related to each other, and in the sales fact table, the time the time key and the shipping fact table time key are the same. So instead of writing two copies of it, we write just one dimension table and connect it to the both of the connect with both of the fact tables. So this will be called as the galaxy schema or fact constellation. A fact constellation has multiple fact table and fact tables. So here they are related. The sales fact table is same as the star schema. So here we have the we connect shared one time dimension table between these two. In data warehouse schemas, there are multidimensional schemas, and is defined using the data mining query languages. And for this we use the div definition and dimension definition can be used for defining the data warehouse and data mart. That's all about the data warehouse schema.